Today we're looking at section 5.1, which is the mid-segment theorem and coordinate proof. You should have already done your pre-notes last Friday, so now today as we go through, you should have the terms and theorems copied down. We're going to add notes to those terms and theorems, as well as look at some examples. You will then do some practice problems, and then you'll have the rest of the period to do your homework. So if we look at the first part of this section, which is the mid-segment of a triangle. A mid-segment of a triangle is a segment that connects the two midpoints to the two sides of the triangle. Has the word mid in it, we want to think midpoint. Kind of our midpoint has mid, and that's in the middle. So if we start with just this diagram we know that M, N, and P are all midpoints. And we can mark them accordingly. We know in the middle of each segment. So, by that definition, that means segment MP, segment NP, and segment MN are mid-segments. That is those three lines inside the diagram. So, when you identify a mid-segment, we look for a segment that goes from each midpoint and it connects. And inside any triangle, we would have three different mid-segments. Next, we go to the mid-segment theorem, which now we actually apply it. And the mid-segment theorem says the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So, let's start off with saying if MP is a mid-segment, then we know two things. First, that it's parallel to the third side, and second, it's half as long as the other side, which would be AC, or we would say 1/2 AC equals MP. For those that don't like fractions, well, we could say 2 times MP equals AC. What we're really thinking here is we take this value, we double it to give us the whole length of the side, or we take half of that side, and that's the mid-segment. And that relationship will always exist within a mid-segment. Doesn't matter if it was the other mid-segment, one going in this direction, it would still be half of that side it's parallel to. So that's really what we're going to do with the mid-segment. Yes, we know it needs to be parallel, but it's that half as long as that side is that key thing, and where we're going to see the problems come from. So let's look at a couple examples. In the first one, they've given us just a basic mid-segment. We need to find x, y, z. And in the second one, we need to solve for x. So, if we look at it, we have 7 as the mid-segment, and x is the side it's parallel to. We know these are parallel because it's a meeting at midpoints. So, to get x, we would double the 7, and it would be 14. If we look at y, well, we know y is a part of that outside side, which has a midpoint. So if this is 6, it means y is also 6. And finally, for z, since we know 16 is the entire length of the side, we want z, which is just a portion, the portion that goes from the midpoint to a vertex. It would be half of that, so it would be 8. So, basic filling in the values to a diagram. Then we go to a little bit more complex of a problem, where we need to solve for x. We do not set these two equal to each other, because they are not equal to each other. 2x plus 1 is a mid-segment. So, by our rule, we know that this is half the whole side. So we could say 2x plus 1 equals 1/2 6x minus 8. And if we don't like fractions, we also know we could double this side to get the whole side. So that would be 2 times 2x plus 1 equals 6x minus 8. Now, looking at these two, and really either one we use to solve, it doesn't matter. If I had this 1/2 and I wanted to move it to the other side, well, I'd multiply both sides by 2, and it would look like our top one. if I had this 2 here and I wanted to move it to the other side, I would divide both sides by 2, so it would look like the bottom one. A key thing I would look for, if I had to take half of something, yes, half is nice because it does give us smaller numbers, but if they're both even, it's going to make it nicer. So I generally use that 1/2 for the whole side when they're both even. If there are odd numbers, like maybe if I was taking half of this side, I wouldn't want to do that because then I'm stuck with decimals or fractions, and we all know how we feel about those. So let's use the bottom one here. I get 2x plus 1 equals 3x minus 4. Make sure you take half of both values. If I subtract 2x from both sides, I get 1 equals x minus 4. Add 4 to both sides, we get x equals 5. Now, we quickly check. 2 times 5 plus 1 is 11. 5 times 6, or 6 times 5 minus 8, would be 30 minus 8, or 22. Yep, 11 and 22, so the values match. Okay, so we also have some practice problems listed. You're going to try those on your own. They're also listed on your packet, so we're going to come back to those. But before we get some practice with those, we're going to jump and look at the second part of this section, which is coordinate proof. So you can just leave space at the end for those practice problems. Let's go to coordinate proof. And coordinate proof is a proof that involves placing geometric figures in a coordinate plane. So instead of just having some shape floating there through space, and we're now give it a grid where it's on an exact graph, or maybe we just give it axes, where we're going to treat them as variables for the values. So I have this triangle here. It's placed on the graph. I need to give it coordinates. Well, we know the origin is always going to be 0, 0. If I look along this side, this point is 9 units out, so this point would be 9, 0. The vertex, my third point, I go 6 over and 6 up, so that coordinate is 6, 6. So I've given the values to all the vertices in that shape. Now why this coordinate proof is relevant? Maybe I'm looking at this problem now and I want to find the midpoint. I want to find the distance. I want to look at the slope. With having these coordinates, I would now use them, because with all those formulas, we would just plug them in. So it's getting that basic setup. But the unfortunate thing is we won't always have those numbers there. We'll be given something like this shape we have on the right, this rectangle. We need to give it values. So let's say we know this rectangle has a base of A and a height of B. Well, I know the coordinates for the bottom left point is still 0, 0. That's the origin. That doesn't change. And whenever we really use these, we're going to have them using the origin. We're going to have usually a side going along the x-axis, a side going along the vertical axis if possible, just because they make things nicer. I could have it floating out here through space, but we want to make it as easy as possible. We seem to like that. So now I need this coordinate. This coordinate is A units away from 0, 0. It didn't go up or down any, it just went A units to the right. So its coordinate is A, 0. The top left corner went up B units. So that would be 0, B. Last, our top right point went over A to the right, up B. So its coordinates would be A, B. We don't know what the values of A and B are here, but that's fine. We're, again, just trying to label the coordinates. Once we had that, we could look at the midpoint. We could look at the slope. We could use different things with those variables and give them values different than we normally could if it wasn't a graph there, if it was just a shape. So let's look at a couple examples. So determine the missing coordinates in the diagram. Do not add new variables. It'd be really nice if we could just pick our own letters, pick the letter that starts your name, and we could fill them in, but we can't do that. We have to give take what they've given us. So if we look, we have DO is our point out here on the bottom right. DR is our point in the top corner. Well, just by that, I know, well, first of all, we know this one. This one's 0, 0, because that's at the origin. But to get from this point out to the right edge, well, we went out to in the x direction. We were at 0, now we're at D. So that means we went out D units. Then from here, we're still at D, but now we went up to R. So we went up R units. So really, we're now looking at that top left point. So from the origin at 0, 0, to get there, I didn't move left or right any. So that's still D, or it's still 0. But to get up to there, it went up R units. So it'd be 0, R would be my coordinates. Okay, hopefully that's not too bad. Now let's look at one where we actually need to use it here. So we're actually going to look at the midpoint. This is our second example here. So we want to find the midpoint of segment AB. We have H, we have K, those are our values. We don't need to give them numbers because we're just assigning them variables. Now, of course, since we always remember the midpoint formula, let's just write it down. Thing to note, just remember, it's x1 plus x2 divided by 2. It's finding the averages of the x, y1 plus y2, finding the averages of the y. So, we're looking from A to B. So, average of the x's, average of the y's. Before we do that, let's make sure we're clear on how we got to those points. If I was at 0, 0, I went up to A, k units. So my height of this rectangle we could call k. From there, I went over to the right, h units. So the base, or the length, would be h. Not necessary in solving it, but it's good to make sure we're clear where those values are coming from. So now we're going to find midpoint. So my x values are 0 plus h, dividing that by 2, k plus k, dividing that by 2. Well, I get h over 2, and I get 2k over 2. Well, h over 2 stays the same, but now 2k over 2 can just become k. So the coordinates at this midpoint would be h over 2 and k. Now, does that make sense? I'm still up k units because my y value is still k. So I'm still had to go up k. But now instead of going from 0 to h, I only go half the distance. And really that's what the midpoint is. It's half the distance from the segment. So I'm not going to go h units. I'm going to go half of that. And that would be my coordinates. So now you're going to try some on your own. You have your own example for the coordinate proof. I want you to try that one, as well as the example for mid-segment. You're going to try those. We're going to check our answers and then do some homework.